This week we'll be talking about how to make your program run differently based on different conditions. So far, MATLAB has executed the statements that you gave it in the order that you gave them. In other words, it used sequential control. That's its default behavior. Sequential control is the most natural and the most common sequence in any program written in any programming language, and it's the primary example of a control construct. A control construct is just a method used by MATLAB to select the next statement to be executed after it's done with the current one. In this lesson, we'll introduce some constructs that tell MATLAB to select its next statement based on some condition. A construct that does this is called selection, or some people call it branching. The most common selection construct is the if statement. Let's introduce it with an example. The guessMyNumber function is a single if statement. It starts with the if keyword, followed by the condition x equals 2. This pair of equal signs is a new operator. It means equal to, or is equal to. The statement that follows the line with the if keyword will be executed if and only if this condition is true. In this case, if and only if x equals 2. The if statement is terminated by the end keyword. Let's see this function in action.
And here it is in the editor. Let's try it with a few bad guesses. How about running it with 3? And how about 0? Nothing visible happens. Now it's how it's supposed to be, since our function doesn't do anything with a bad guess. It evaluates the x double equals 2 condition here, and if it's false, as it would be if x was 3 or 0, it skips this fprintf here inside the if statement, and then the function returns. Now let's try it with the correct number. We should see something different. Indeed we do. We see the congratulatory printout. The condition was true this time. X is 2. X double equals 2 evaluates to true. So we executed the fprintf statement inside the if statement, and the function ended again.
The control flow of the if statement is best illustrated by a figure. The blue dot represents the control statement, in this case the if statement. The blue lines with the arrows show the possible paths that MATLAB can follow. The branch that goes off to the left represents the case when the condition is true, that is x equals 2. The box labeled block represents the set of statements inside the if statement that will be executed if this branch is taken. The right branch represents the case when the condition is false. In that case, we go straight to the next statement after the if statement, that is, after the end keyword that terminates the if statement. This figure highlights in red the flow of control when the condition is true. As you can see, in this case, MATLAB executes the block of statements inside the if statement. This figure shows the case when the condition is false. This time the red line shows that we skip the block statements inside the if statement and jump past it to the statement after the if statement. What if we want to do something when the condition is false as well? In other words, what if we wanted to execute one set of statements when the condition is true and a different set when it's false? Let's improve our guessMyNumber function just a tiny bit by trying to cheer up the poor user who picks the wrong number. Both the function and the if statement start out the same way as before. But after the first fprintf statement, we see a new keyword, else. This else has two roles. First, it signifies the end of the block of code that needs to be executed when the condition is true. And second, it signifies the beginning of the block of code that needs to be executed when the condition is false. This new statement is called an if-else statement. As you can see, our new and improved guessMyNumber function prints out an encouraging message if the user's guess is wrong. The control flow of the if-else statement is illustrated by this figure. Here again, the blue dot represents the control statement, in this case the if-else statement. And again, the blue lines with the arrows show the possible paths that MATLAB can follow through the statement. The branch that goes off to the left represents the case when the condition is true, that is, x equals 2. The box labeled block 1 represents the set of statements that will be executed when this branch is taken. These statements are the ones that come before the else keyword. The branch that goes straight down represents the case when the condition is false, that is, x is not equal to 2. The box labeled block 2 represents the set of statements that will be executed when this branch is taken. And these statements are the ones that come after the else keyword. This figure highlights in red the actual flow of control when the condition is true. As you can see in this case, MATLAB executes only the block of statements that come before the else keyword. And this figure shows the case when the condition is false. This time, the red line shows that we skip the statements inside block 1 and instead execute only block 2, which is the set of statements after the else keyword. Okay, let's try this function in MATLAB.
Here's our new and improved version in the editor. Let's take a wild guess and guess 3. Like we did before. And, well, this time we get a little bit more information. Not right, but a good guess. MATLAB, of course, evaluated this exact same condition. 3 is equal to 2, and again came up with false. But instead of just quitting, this time it went to the statement, or the block of statements, in this case just one of them, immediately after the else keyword, and that brought us to the fprintf, which printed out this little bit more encouraging message. Now what happens if we guess right? Well, let's do that. Let's go right straight to that, and we get the congratulatory message. The opposite happened this time. The condition evaluated to true, so the statement immediately after the condition executed. To recap, when an if-else statement is in our program, we're guaranteed that it will execute exactly one set of statements. Either the statements between the condition, here, and the else keyword, here, and that's carried out when the condition is true, or the statements between the else keyword and the end, which closes the if-else statement, when the condition is false. Okay, that's it for the if-else statement. But guess what? There's one more version of the if statement. And here it is in a third version of the guess my number function. It's the last one, and that's a promise. One change that has nothing to do with the new version is that the number 2 here seemed boring. So we changed it to 42, which I'm sure you'll agree is far more interesting. More importantly, we see a new keyword here, else if. This is an if, else if, else statement. There has to be a condition after the else if. In this case, we have x less than 42, just as there had to be a condition after the if keyword, x double equals 42 in this case. You can probably guess how this thing works. Let's suppose x is equal to 42. Then we carry out this statement here and we're done. Let's suppose it's false. And we skip that. We come to the else if and we check if it's less than 42. We carry this out. Let's suppose that's false. Then we come down and we do the else part. Let's call the function with 41. The first condition with x equals 42 was false, so MATLAB checked the second condition, the one after the else if keyword here. That turned out to be true, so we printed the too small message. If we run it with 43, you can see that we get the too big message. That's because x was neither equal to 42 nor less than 42. So both of these failed, and we went to the else condition. A few remarks about this version of the if statement. First, the else branch is optional, just as it was before. You can simply omit the else and close the if-else if statement with the end keyword. And if we leave that branch off, like this, I'm just going to hit delete now, we're left with an if-else if statement. Second, whether you have the else branch or not, you can have as many else-if branches as you want. They come one after another, right in here. We'll see an example of this a little later. Okay, counting the if-else-if statement that you're looking at right now, we've seen 4 versions of the if statement. An if, an if-else, an if-else-if-else, and an if-else-if. To understand how these various versions of the if statement are related, you can think of each of them as a fork in the road when you're driving. The most complicated one is the last one we saw before this one. I can get back to that by coming up here and hitting this undo button, and there we are. This is a fork in the road with 3 branches. 1, 2, 3. You're going to drive down one of these forks to get to the next statement in the program. If you drop the else if, again I'm going to hit the delete, then there are just 2 branches. If you add more else ifs, there will be more branches. And regardless of how many else ifs there are, even if there aren't any at all, if you get rid of the else, then when all the conditions are false, you'll just detour around the fork and drive directly to the statement that comes after the if statement. Okay, end of remarks and end of all these versions of Guess My Number.